From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
Our application portfolio for additive is a lot of land-based and sea-based radar systems. And then there's obviously the missile and airborne type of applications in that domain. So right now we're focused on both of them, but we're the closest to going over the goal line with the land-based type of radar systems.
That was Travis Mayberry. Travis is the technical area lead for additive manufacturing at Raytheon Missiles and Defense. He's been with Raytheon for 13 years and recently graduated with his doctorate in mechanical engineering from Southern Methodist University through the Raytheon Advanced Studies Program while working part-time. He has a background in design, thermal systems architecture, and metal additive manufacturing. He currently leads the additive manufacturing internal research and development efforts for Raytheon Missiles and Defense and is involved in a number of cross-Raytheon efforts in additive. He's presented over 60 technical presentations internally and externally and holds 13 patents and 4 trade secrets with Raytheon. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast, where you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials, qualification, or general additive manufacturing support, reach out to the 3 Degrees team through our website or via email at info@3degreescompany.com. All right, Travis, thank you so much for joining the show today. Really excited for the conversation. I like to start all these episodes with kind of the history of who I'm talking to and going all the way back. So maybe tell us a little bit about where you grew up, kind of what that was like, and maybe some of those early days getting you on the path towards manufacturing and engineering.
Yeah, absolutely. Thanks for having me on. Really excited to talk to you today. So I guess if I were to go back and kind of what got me started down this path, it's always complicated, right? It's different for everybody. I live in Texas. I grew up in Texas, born in the Dallas area, and born here, grew up through high school, and went to undergrad at the University of North Texas up in Denton. And then I started doing a co-op with Raytheon, where I work now. Have worked here for the past 13 years. And after I started full-time, I went back and got my master's at SMU while I was working. And long story short, I just graduated with my doctorate last December, in December 21 from SMU in mechanical engineering, and worked at Raytheon the whole time. So it's been a long road to get here, but it's really funny when I look back at kind of what I wanted to do as a kid. I think that I always kind of wanted to build something that I could, put my name on and point to it and say, I made that. That's something that I was a part of. And I think I get that being a mechanical engineer. I think originally I wanted to be an architect and go to, UT or something. And that's the University of Texas, by the way, for anyone out in Tennessee who thinks that UT is University of Tennessee. But
you got your big quarterback coming next year. So
yeah. No, I know. But I thought I wanted to go there. Life had a different path for me, but my attitude's always been, life's what you make it good. And so whatever situation you think is not what you intended or what you want it to be in, you have the power to make it whatever you want it to be. It can be as awful or as awesome as you totally put your energy into. So, I mean, that's how I got out of undergrad, and that's what got me through undergrad. And things turned out really well after undergrad. I landed a job at Raytheon and have been totally happy here in my time here. And, I met my wife in undergrad and got a lot of different experiences. So it was a totally awesome time, and it's led me down this path to where I am today. So very grateful for the opportunities I've had.
Awesome. And so maybe talk a little bit about kind of the North Texas area. I mean, like a lot of people think of Texas, there's the Houston area with kind of oil and gas. So Does like the North Texas area kind of Dallas area, I suppose, like have like an industry culture or like manufacturing culture? Like what is the, like, what do people do like when you're going into mechanical engineering? Like what are the targets that people have in mind when they're kind of going on the path that you were?
Yeah. So, when I was in undergrad, I wasn't really sure what I was going to wind up doing. I had no idea that I would wind up in manufacturing, which is really what I do a lot of today. My undergrad was mechanical engineering technology, which is the hands-on version of mechanical engineering. You're in the machine shop, with a lathe and a CNC and welding equipment and all sorts of different stuff, finishing, and you're in there really getting your hands dirty. And so, North Texas has that mechanical engineering technology. The University of North Texas has a mechanical engineering technology program that I think is wonderful. We have hired many more people after I hired into Raytheon in the North Texas area from that program, because really they know what a quarter 20 bolt is. And that's actually one of my interview questions when we're hiring new people onto the program is, hey, differential equations is great, and Cal 3 and linear algebra, all that's great. But do you know what a quarter 20 bolt is? And if they can say what the quarter is and what the 20 is, that's the outside diameter, by the way, and the pitch of the threads. But if to know that level of detail, I learned that in North Texas, and it helped me be successful in my job today. So I didn't really know I was going into manufacturing. I thought I was going into mechanical engineering, a lot of the design stuff. But it turns out once you get into the design stuff, it doesn't matter how good you are at math. When you're doing the design, you will always be responsible for the fabrication and seeing through that part until it's actually integrated into a system and it's out in the field. And in my case, protecting our troops overseas. So, I mean, the integrity and keeping an open mind to, everything you design has to be manufactured somehow. Just that mentality is so valuable. And I don't know if every school really preaches that, but I certainly try to preach it. I have a background in mechanical design, and I have done that for my entire career. But you learn really quickly that manufacturing goes hand in hand. It is not a separate equation. It is fully integrated into design and anything you want to do for mechanical engineering wise.
Yeah, it's so interesting. Kind of that story you kind of described is like a lot of people, I imagine, that go into mechanical engineering like to work with their hands, like to build stuff, but then so much of it is theoretical and doing the equations, doing the computer related stuff, and I think in a lot of places it was a lost art, or underemphasized, certainly, like the ability to kind of go and actually build something, fabricate it, think through all the different steps and pieces that are required. Even if you may not be doing it, your designs are informing how someone should do it. And
right.
It's that's awesome that to kind of get that experience. So with that, I mean, as you kind of developed in your career, how valuable was that early on in having kind of the hands-on kind of experience when you're kind of a new hire at Raytheon and kind of starting out your career? Was it easier to kind of embed into the personality of the company or the group that you were working with?
Oh, 100%. Actually, what got me my job at Raytheon was we had some class in my junior year in undergrad at the University of North Texas, and I was like the shop manager or something. The class elected me to be the manager of the project or whatever. And so part of that was safety and, making sure everybody had the right shoes on and were wearing their eye protection and all that stuff, which is so important. And I actually leveraged that and spun that in a nice way in my resume. And the way I got into Raytheon was with the environmental health and safety team. So I actually hired in as an EHS intern, doing all the different safety stuff that you would do at a company. So it was just a summer internship, and I parlayed that into a mechanical engineering co-op where I was working part-time and going to school full-time in the fall and spring semesters. And it was at Raytheon here in the North Texas area. And so it's just a 30-minute drive from anywhere that there's a Raytheon basically. And so I did that, and that's how I got in with the team. And I was using my experience from the shop floor, basically saying, yeah, I know what a datum is, and I know what all these different call outs on a drawing are. And that was really helpful for me because I came in with just a little bit more experience than someone graduating from a typical university for mechanical engineering, the background that they had. So we've hired people like that, many people like that since, because we really do need people to be able to hit the ground running and know what a quarter 20 bolt is.
Sure. And so maybe talk a little bit about Raytheon just at a high level for those who may not be super familiar with the company. Like, it's a massive company, but kind of maybe drill down of like kind of at a high level, what does it do? And then maybe your particular group or focus industry area that you've been involved in.
Yeah. So Raytheon is I'm going to go back to pre-2020, before the merger with United. We recently merged with United Technologies. But before that, it was largely a defense company, and it still is largely a defense company. So Raytheon makes, they call it sensing and effectors. So they'll make radars and optic systems that go in space, on aircraft, on radars parked on land, or Navy systems in the sea or undersea. We're in the cyber domain. I mean, it is it's a large defense company. It's one of the main prime contractors up there with Lockheed and Boeing and Northrop. And so, we do the sensing and effectors, and the effectors are the things that go boom. And so, you have missiles and lasers and high power microwave and all sorts of different stuff, right? But those are the two big branches of what Raytheon does. And we also have, now with the merger with United Technologies, now we're Raytheon Technologies. And so we still have all of the old defense work, and a lot of it is booming right now. But we now have Pratt & Whitney and Collins Aerospace as well. So we have a lot of capability in the company. It's a very large company now. You can go look up the sales and the employees. I won't misquote it right now, but it's a behemoth of a company. We were trying to wrap our minds around the old company, how big old Raytheon was, and now we're global, worldwide, big kind of company now. So it's huge. There's a lot of different types of products in here. There's a lot of different manufacturing needs, and it's been interesting to kind of see what the type of work I have done as a designer, and what I have found to be the interesting piece of that is really the manufacturing process. And so I'm not a manufacturing engineer, but I kind of am at the end of the day. I do a lot of work with additive manufacturing now. Over the years, that's a long story too, but I've really, for the past 8 or so years, I've been very deeply involved with metal additive manufacturing, metal powder bed fusion, wire fed directed energy deposition, binder jet, you name it. But we do a lot of that in my business unit. I'm part of the business unit of Raytheon Missiles and Defense, so that's 1/4 of the larger Raytheon Technologies, and I'm the additive manufacturing lead for that business unit. So it's endless. There's an endless amount of different manufacturing challenges, and additive really is one tool in the tool belt.
And where was your first experience with additive? When did that come into the mix?
Yeah, great question. So I had a very influential mentor named Jim Pruitt. He's retired now, but whenever I was getting my master's, I guess it was sometime between 2012 and 2014, I met Jim Pruitt, and he is just a prolific inventor at the company. Changed my way of thinking about problems, exposed me to a lot of new manufacturing processes, to be totally honest. And additive manufacturing was one of those. And we would do it for rapid prototyping. His whole thing was, if you want to be successful with internal research and development dollars and get funded for the next year, you need to have two things. You need to file a bunch of intellectual property disclosures, so patent disclosures, and you need to have hardware on the table, no matter what it is. So IP and hardware. So I've preached that since then. If there's anyone who has ever been on one of my teams listening, that's where that came from. I preach that relentlessly, IP and hardware. And so he exposed me to additive for the first time. And when I was going back for my doctorate, I applied for the Raytheon Advanced Studies Program, which is a scholarship program that Raytheon has to send you back to go get your advanced degree. And they'll pay for the full tuition instead of just a portion of it and the standard tuition reimbursement. And they'll also give you time off to go back to school. So they'll actually give you a charge number you can charge out to for up to half time if you're going to do work study. So as I was going into that program, it's a long application process. I didn't think I was going to get into it, but I told them I was going to go research additive manufacturing for my doctorate research. And as anyone who's been through a doctorate knows, it's a long and windy road. And so we ended up not doing that, but that's what got me sold into the program. And I guess what I was doing for the other 20 hours a week. So I was 20 hours a week at school and 20 hours a week at Raytheon. And so that 20 hours at Raytheon, I got involved with a bunch of different internal research and development projects on additive manufacturing. So additive IRAD is what we call that. So that's really how I started getting into that in 2014, 2015. I took on more and more responsibility. My research focus at school was in thermal management. So it's the Doctor of Engineering and Mechanical Engineering from Southern Methodist University in Dallas. And my research focus was actually in the thermal track for my research area was oscillating heat pipes. If anybody knows anything about an oscillating heat pipe, I know a little bit about them over the past 7 years. So that's actually what my research ended up being on. There was nothing additive about it, though it's certainly feasible to go additively manufacture an oscillating heat pipe. Wasn't allowed to do that because it would be an IP conflict with whatever Raytheon wanted to hold back. So I did something much more general, and it was initial conditions for liquid vapor distributions and oscillating heat pipes. So that's all I'll say about it. I don't want to give anyone else tired head about that research, but I thought it was interesting. I think that part of the industry thought it was interesting too. And so, but in that meantime, right, over the course of the 7 years I was in the program, trying to graduate, I got more and more involved with metal additive manufacturing at Raytheon. And so it has led me here today. Like I said, I graduated in December last year, and I'm now doing a lot more with the technology at the company. And I guess that's kind of how I got into it. It was a mentor that exposed me to it. I pitched it as my advanced studies project. That didn't work out. I did something else, but I started doing the additive IRAD stuff at Raytheon in parallel. So it's led to a very interesting time in additive manufacturing, and I think we're definitely on a precipice right now of industrialized additive manufacturing being available as kind of a commodity manufacturing process. I think that's a realistic near-term thing for some of the alloy sets that are available, and certainly with the machines that are coming out focused on higher productivity, lower cost additive manufacturing. So it's an exciting time.
Sure. And so maybe talk a little bit about, I've got kind of two threads that I want to pull on a little bit here with that answer. So the first one is Raytheon's a huge company, as you mentioned. I worked for a little bit of time at not a similar size company, but like a big company, 3M. And one of the things that I have kind of observed is that it's very easy to kind of get in your own silo and kind of not necessarily get lost, but like, hey, that's your lane, and you're going to kind of see that particular lane. But like, there's such a big behemoth of other stuff going on. And like, so finding the nodes, like it sounds like you did with Jim, who has had experience a lot longer than you in it, but but also would it be able to see maybe that 30,000 foot view is like, here's how you actually move the ball ahead in a big company? Because I think oftentimes that's people's complaints about large companies or even companies in general is like they're not good at making decisions, right? And so it sounds like early on you were able to figure out like, okay, what are the things I need to do to like move the chess pieces in place to get someone to move where I want them to be.
So I'm glad you mentioned that. So Jim was very influential from like a technical, hey, change the way you think. Here's a different perspective to approach problems. I credit him with a lot of things. The person who is the chess master, like you're talking about, is a lady named Mary Herndon. She's a senior engineering fellow at the company now. And I credit her solely for helping me get into the Advanced Studies program, getting involved with the additive manufacturing community, and really graduating. She's been at my side for this entire time, since 2014 or whatever. It's been an incredible journey with her. She is absolutely the person that helped me navigate all that, because it is such a huge company, and you have to. I know people approach problems in a different way. Some people want all the details first, and then they can understand the big picture. Some people want the big picture first, and then they can go find the details. She's helpful in either capacity, but you kind of hear about these different things, and then you hear a new acronym like IRAD or CRAD or something, and you're like, what is that? How does that fit in? Who is this person? How do they plug into the larger technology strategy at the company? She was like essential in helping me navigate that, and I've tried to help other people on my teams navigate that in the past years, because it's an important thing to understand, especially with the company this big. Even Raytheon Missiles and Defense, RMD, the business unit that I work at, it's huge. We have a huge presence in the Northeast, in the Massachusetts area. We have a huge presence in Arizona, in the Tucson area, and I'm in North Texas. We have a presence here too. And so it's just a huge company. And then there's the other three businesses that have technical experts in aluminum metal powder bed fusion that are very closely aligned to what I'm interested in, and they have different perspectives and experience. And so it's trying to navigate all of those different pieces and making sure that you're talking to people to get input on your project, but also that people are aware of you so that they can ask you questions whenever they need it, right? Because I think we had one of our CEOs a long time ago. They said, if Raytheon only knew what Raytheon knew, think of the power of that. And that's all. The essence of that is, if we can introduce each other to each other, and have a network of people that talk, it's a exponential function of learning, right? So I think the additive community within Raytheon, and Raytheon Technologies now, they do a really good job at that. We are very well plugged in with each other. We know what each other are doing. We merged in 2020, and we're still learning about each other, and we're still trying to make it out to whatever site in whatever state, and ask questions and get plugged in. But it's always a learning opportunity.
And on that front, I mean, the ability to balance doing a PhD and working full time. Can you maybe just walk us through like what would your typical week look like in terms of how you manage your time and what you were doing, kind of trying to balance both of those?
Yeah, I actually saved off some of my old schedules just because it was so ridiculous, like studying for the qualifier exam and then going to some IRAD tech review for, our tech directors. And, it was pretty incredible, but I think that it was good practice for me to establish hard boundaries for my life. And so it was very much, I am going to be at work from however early in the morning I need to until about 11 o'clock or noon. And then I'm going to leave my computer at home, leave my work phone at home. Maybe I'd take my work phone if I really needed to, but I was going to physically move to the lab on campus or go to the library if I'm, in coursework or studying for qualifiers. But I will physically move somewhere else where I'm not at my desk, able to just just check that email, or I'm just going to finish this report, or whatever it was that could really wait until the next morning. But to draw that boundary and say, I'm going to go over here and do this for the next however many hours into the evening that I need to go do it. And my wife I absolutely love my wife. She was very understanding through all of that, but certainly sick and tired of it by the end. But I mean, it was hard. It was hard to have that kind of boundary. But I think I've taken some of that experience back into my life now and say, I'm able to still draw those boundaries for work, right? I will start as early in the morning as I need to. That's no problem. I can set an alarm, but when it comes to like 5 o'clock or whenever we're going to be wrapping up for the day, I need to go make dinner, or we got plans with friends in the evening. I carry that boundary mentality with me today to say, I'm going to hang it up today. This will have to get done tomorrow. And I'll wake up at 3 a.m. I don't care, but this is my life, and I got to have those boundaries. So it was practice in that regard, I guess.
Yeah. And avoiding this distraction of whether it's internal Raytheon emails while you're doing lab work. And it's a
totally.
good skill. I mean, like
totally.
It's so easy these days with all the different options and devices and websites that people have, not to mention your work email,
home.
Right?
Working from home. I mean, that is, it was perfect training for that, because I worked from home before we were working from home for COVID. I've had years of practice of keeping that boundary strong. So it's been good, and you're never perfect, right? But it's definitely good to, shut it down, turn the screens off, and, put it away. Just walk away. Don't walk by. Don't leave your email up. But that can be a hard thing to figure out at first, I'm sure.
It seems like you've done a really awesome job at, like, as you stayed at Raytheon for a number of years now, and finding different ways, different groups, different challenges along the way to kind of continue to build your own career. So do you want to talk a little bit about kind of what your mentality is, or kind of maybe just any advice that you would have on, like, someone's considering a large company and maybe a little bit concerned about kind of like, how do I kind of get up the chain, because it seems so daunting, right? Like, there's a mountain of people and different groups and things like that. Like, what sorts of insights might you have on kind of how do you build a career that's exciting and challenging for you in a large company?
Yeah, that is a daunting task. And that's something that I struggled with for a while too, was, man, how do I get there? What I want to be a fellow. I'm going to be a fellow. That's my mentality, is I'm going to be a fellow. And it's
so what's a fellow for those who might like
may not know? Yeah. A fellow is it's like you're like the 1 or 2% in the engineering community. You have been recognized out of your peers as an expert in that technical field, and so they will mint you a fellow. And it's a really neat honor. You get different kind of work. You're the person that people go to for a given problem and given technical area. So it's a really neat thing that I think a lot of the major defense contractors at least do. And so it's a really neat thing. So, how do you promote? How do you put yourself in a position like that? My advice would be to really just understand that you can do whatever you want to do. And that's as simple as it is. I think that, and I tell the new hires this, and they probably don't need to hear this, on day one, but, look, we hired you in as a mechanical engineer. You're going to do designs and drawings for this radar system, and that's going to be awesome. But hey, in like 4 or 5 years, you're probably going to be sick and tired of it. You're going to have some bureaucratic stuff in front of you that is just cumbersome. You don't want to deal with it anymore. Realizing that you can go find an IRAD project, these R&D projects, they're out there. These people are out there. There's a whole innovation community. I don't care what company you're in. There's an innovation community. You can plug in with them. And I didn't know that until Mary Herndon showed that to me. Jim Pruitt taught me how to think. Mary Herndon showed me where the people were and, where the projects were and how to get involved, how to introduce yourself, how to be responsible for your work. And so just an incredible, fast path to learning all that kind of stuff. But you could really just do whatever you want to do. So, I hired in as a mechanical engineer doing exactly what I just said, designs, drawing, release, fab, integration, test, dealing with stuff out in the field, wherever these systems were fielded. And it was very interesting and very fulfilling work. And at the same time, I realized, there are other things at this company to do that might be more interesting to me. And so I found them, and I am totally confident that anyone else can find them too. You don't have to go apply for a job. If it's in the company, you can just introduce yourself and demonstrate some level of competency, and, ask for a couple hours a week here and there just to get involved, join the meetings. But before you know it, they're going to need someone to do this one task, and you can pick that up. And then the next year, they're going to need someone to run this part of the project, and you can be responsible for that. And then you can go learn how to propose your own IRAD project, or be involved with a new project pursuit. You can help write proposals for new contracts that are with interesting customers that have interesting work and funding in your realm. Additive manufacturing is one of them, but there's a lot out there, certainly. And you can climb the ladder that way, but really you're inventing your own ladder at the end of the day. There's a technology that's of interest to your company, and if nobody's doing it, then why not you? Why not go fight for that money, make the case to whoever needs to hear it, and then just be scrappy with how you get your funding. I think that's all we do here is just be scrappy and creative about what kind of funding you go after and where you get it. But you can really piece together some very meaningful work. And I've learned that from Jeff Shoebrooks and a whole host of other people at this company too. But it's just, you'll meet new people along the way. You'll meet new challenges. You'll meet something that's interesting. People will say that's crazy, don't do it. And then you'll go do it and show them that it wasn't crazy after all. And there is a path. It just wasn't illuminated yet. And you can be the person that helps illuminate that path. So that would be my advice.
Yeah. And it's one of those things where too, like, you may not think about it I never thought about it in that context, where although you're in a large company and there's a lot of things in place, like a lot of the same skills that a startup would do, or kind of building your own business, like you got to go advocate for yourself, market your idea, 100%. Pitch it, do all the ROI and why is this important, and kind of convince others to do it. So as an engineer, you're always trying to kind of do a lot of that same thing, regardless of whether it's a big company or a small company.
I always say that, I've got a doctorate, but I swear I'm more of a salesman than anything at the end of the day, just trying to advocate for this technology. Advocate is probably a better word for it, but you're definitely in, like, trying to demonstrate that what you're doing is valuable, and intrinsically that it's valuable, but it has to be valuable for the right reasons, for whatever program you're trying to insert it on, or however you're trying to transition it out of the development phase into like an actual capability. There's a lot that goes on to that end. So it's a journey. It's going to be different for everybody, but you can definitely your career is what you make it good, make it interesting, make it something that you want to do. You have the opportunity to be an entrepreneur at a large company. So you're in like this ocean of a company, like a Raytheon or a Lockheed or Boeing, right? It's endless, the amount of people and expertise that are here. But at the same time, you can be in charge of creating your own, your own little pocket of expertise, your own pocket of something that will benefit the larger company, but nobody's looking at. And what I tell the new employees too is that, there really aren't any rules either. There certainly are rules, but, a lot of them are not hard and fast rules. There's always a reason or a justification you can apply to go do something that you want to do, if you can justify it the right way. And so, I would challenge them if there's any reason that they're saying they can't do that, or nobody wants that. I would just inherently challenge that and want to really sit down and talk through it, because it takes a lot to compel me otherwise on that topic. I think you can really do whatever you want to do at the end of the day.
Absolutely. And so one of the switching topics a little bit, I've always found this interesting to ask, and it's a highly dependent based on the company and kind of the projects that people are on. But as we think about kind of a big company like Raytheon, certainly you manufacture, and you start all the way from like design, R&D, kind of developing concepts into some manufacture. But I imagine also you work with a lot of manufacturing partners to build components or compile components, assemble components. And so do you want to talk a little bit about kind of what is the ecosystem of kind of like defense manufacturing? Kind of like, what does that look like in terms of, obviously there's the DoD and all the branches and they've got needs, and you're pitching new technology. There's small manufacturers that have to build some of that, or medium-sized manufacturers, and kind of what does that ecosystem look like, maybe just in terms of your context and what you're doing on the additive side?
Yeah. So there's a lot to that question. And so just with respect to additive, maybe, we're at a point right now where we have a relatively firm understanding of what it takes to have a good quality additive part. And I will say that I am speaking for Raytheon Missiles and Defense. And so our application portfolio for additive is a lot of land-based and sea-based radar systems. And then there's obviously the missile and airborne type of applications in that domain. But right now we're really focused on both of them, but we're the closest to going over the goal line with the land-based type of radar systems, getting additive into those systems. And so, the reason that's really close is because there's a high quantity of those parts, and we think the metal laser powder bed fusion has some good legs in that regard. We think we can make a good cost case if the productivity of the machines and everything is appropriate. And the environment for a land-based system is relatively benign. It's not airborne. We're not launching it into space. We're not flying it at Mach whatever speeds or anything, and have to deal with all this high temperature and vibration profiles. We make this, and we have to go fly it over to wherever it's going to go, sit, and then it sits. So like the most shock and vibe, profile it's going to see is like on the C-130 getting into theater or whatever. And then outside of that, it's just kind of sitting there doing its thing. So cold plate heat exchangers, that type of work is really good for that. We're looking at aluminum. So we're really trying to just figure out this domain. We've proven that the technology is technically viable. So that means that we know it works. We know how to print it. We know, for like a heat exchanger, right? It's not going to leak. We know how to design fins and cores and all sorts of stuff inside. So we understand it's technically viable, but where we're at right now is trying to get the cost story to where it's going to be very competitive with the traditional processes like brazing and all that. And so I think when we get to the point where we start transitioning this into high rate serial production, which is absolutely our focus, we're talking many systems, many units in each system, but it's substantial. But we're getting there, and I think when we get to that point in the next few years, we will be we're starting to engage with the supply base right now, the manufacturing supply base for additive manufacturing, and talking to different vendors that have different size machines, different productivity machines, and just making sure we're aware of everybody. We know what the capabilities are across the industry, but I think the strategy will always be to do a make and a buy. So to have some kind of internal capability where we're doing it. We have our hands on the technology. We're learning, we're improving, but then also leveraging the industry supply base and buying that technology too. So maybe that's the answer to your question, a long-winded answer to your question, but I think it will be a make buy and mostly a buy for the high volume type of production.
Right on. And so kind of just a couple questions left. First one is, I mean, we're kind of back end of 2022, looking out into the next 6 to 12 months. What are you excited about, either work-wise, professional wise, personal, if you got big news?
Yeah.
So what's on your mind?
I think just work-wise, it's that we're so close here. I see some different machine OEMs really taking the challenge of productivity, and productivity, I think, is, in my world, the biggest driver for implementation. When people say, "Well, we've been doing metal additive for decades. Why isn't it everywhere? Why is it taking so long?" Even within our own company, they're like, "Haven't we been investing in this for years? Why aren't we there yet?" I think the biggest barrier is cost, and the way you beat cost down is by improving your productivity. And productivity means more, in my case, cold plate heat exchangers off of one printer in a month. So if you can quantify that and say, I can get X number of these cold plates off of a printer in a month, and I look at a higher productivity machine that can double, triple, quadruple, 10x that, then the cost per part goes down. Just the entire business case changes, right? If you can get 10x of those cold plates off of a single printer in a month, what is the machine cost? How long do you depreciate that? What does that add to the cost of your part? How many machines do you need, right? How many less machines do you need over here? It drives the whole business case, right? And how you bill out your labor, your touch labor, and your machine cost, right? And this is all, anybody who is at a company knows this kind of stuff, but it's like the basics of making a business case around the technology become much easier to swallow when you have these high productivity machines. So I think that the innovations going on with the OEMs right now is extremely exciting. I love that they are listening to industry on these needs. I think thicker layers will increase your productivity, right? Faster scan strategies, more lasers, higher power lasers, new materials, new alloys, right? We're still working with the old alloys, so to speak. I think I heard someone last week talk about that, and it's the original additive alloys that are out there right now. But I think as we keep going forward, that's the most exciting thing for me, is that we really are on the precipice of having high productivity machines, and that is going to drop the cost substantially for this technology. And we are going to see a huge explosion of adoption with the technology, because we've proven to ourselves we can do it. We've proven that we can make a heat exchanger. We've proven all sorts of different things to us, but it dies because it's too expensive, and nobody wants to talk about that. It just is too expensive. So maybe for the niche applications for aerospace and space, where it's onesie twosies kinds of stuff, they can deal with the higher cost and they get a weight benefit, so it's easy to justify any kind of investment or costs in that case. But for our land-based radar system, we're talking about like commodity processes. We're talking very low dollar values, and so we need to have some kind of change in our mindset here of how do we get that cost out, and so that we can realize this technology in a whole new suite of domains where it's not the niche applications, it's the high rate serial production applications. I think that's what I'm the most excited about. We're right there.
Awesome. And so last question, I've been asking this since episode 100 now, is do you have a book recommendation? Something that's been impactful for you and business, personal, whatever it may be?
Yeah. So I think that book, it's a short story, but going back to Jim Pruitt, right? Very influential. He, when I was debating whether or not to go back for my doctorate, right? This was kind of a crazy leap for me to even go apply for this, to think I could do this. 7 years later, it happened, but he I was kind of at a crossroads in my career. I was gonna go do this. I was gonna get into this program and go back part-time and start doing my doctorate, or I was probably going to leave the company and go do something else. I had kind of seen what my work was going to be for the next 10, 20, 40 years. And I was like, yeah, I can do it. It's satisfying just in what the mission is. But I would get very worn down because it was a lot of, it's new applications, but it's not new technology, right? Stuff that people haven't already done. And so I was at a crossroads, and Jim Pruitt gave me a short story, and it was called Jonathan Livingston Seagull. And it's a short story about the seagull, Jonathan. He is looking for his flock, basically. And, he wants to fly the highest and, go catch the most fish and do all that. But all of his other flock is just, they're all there. They're like, why stop doing that? That's a waste of your energy. That's a waste of time. You're annoying people. Don't fly so high. Just fly with the pack. Don't try to catch more fish. We only need this many to eat, and he was just not satisfied with that. So, long story short, he runs off, finds his seagulls, and realizes that there are other people out there like him, that are interested in doing, different things, breaking the rules, so to speak. So that was a really influential book for me. It was a really special book for me. And, yeah, that's my answer to that question.
Awesome. I have to check that out. So cool.
Yeah. It's a short read. You can find it on, I think, the PDFs out there. You can download it for free.
Perfect. Well, Travis, thank you so much for joining the show today. Excited for all that's in store for you in the coming months and years, and look forward to seeing you at one of the shows or America Makes again soon.
Awesome. Thanks, Mike. Appreciate you having me on.